This is the test of Lady Ada.
Yeah.
So you want to do some testing?
Yeah, we're going to try some stuff.
We'll show some stuff off, but if it doesn't work out, we'll be like, hey, it was a test.
Yeah.
All right, do you want to...
Let me go to the overhead of death.
Let's try the overhead of death. Okay. Okay. Can show this. Okay, let's see. Does it work?
Well, hold on a second.
Hold on. Well, I'm just going to keep pressing these buttons.
Yeah, so far so good.
So far so good?
Yeah.
Okay. Okay, I'm pressing. Okay. It's going to block it.
Yeah.
No?
No, it's working.
Oh, great. Well, this is that remote we got.
Alright.
And, yeah, there's 2 knobs. And this on this overhead, you can actually see the infrared transmit. And then there's 4 addresses, 2 buttons. And I kind of like this remote. And then do you want to go to the computer?
Yeah. This is full metal test.
Yeah.
Yeah.
Okay, so this is the device, the IR speed remote control. So I guess you can use this with like model trains and stuff. And it's like $12 or something. I don't know exactly how you buy it. Oh, here you go. Okay. It's like $13 for this. And then I Googled and found they have a data sheet that they wrote about this device. And they say, hey, you know, use this from this thing. And then it's kind of neat. They say you can use personal, non-commercial, and then, you know, have fun and don't be a jerk. And then Gout Munch, I guess, is the designer. They showed the overall schematic, kind of how it works. And then they actually have the RC protocol, so they show, like, all the bits, which is kind of neat because it means you can actually... Like, it's nice. Like, we could have reverse engineered it, but why reverse engineer it if they have a data sheet? Thanks, guys. So, there's a couple different modes. It looks like it sends out 4 nibbles. That's 16 bits of data. There's toggle escape modes, channels. Like, look at each bit is explained. The last nibble is a CRC, basically. So it's the XOR of all the previous data. So that's good to know. There's continuous mode. So do you want to maybe take this apart on the overhead? We could show that.
Yeah, I want to.
You wanted to do that.
I want to move fast and break things.
Okay, let's move things, break things. Okay. So this is a remote. So I put batteries in it, but I can remove the batteries. So the batteries are put in with this screw in. Now it probably, when you press the buttons, it actually turns on the chip. So it's like, it's not, there's no on-off switch. It's just whenever you activate it, you know, it's a chip. It just instantly turns on and transmits. So uses 3 AAA batteries. So that's all good. Got the Lego brick compatibility going on here. And then...
Since they seem to be working, we can look at that other blog post later.
Oh, yeah. Yay! So I'm glad we got this working.
Maybe.
Well, people can watch this and the previous one together.
Whatever. You don't miss something until it's gone.
Jeez.
Well.
Okay. Okay, so let's get all these screws removed. Okay. And, okay, so this is the button and contacts. This is kind of interesting. It's got these 3 contacts, and when you rotate it, you know, it temporarily makes contact with them. And then this is just a cover, plastic cover. This is very nice injection molding because it's Lego, and this is what they're really good at. And then here is the electronics. So you've got this contact set. You saw these 3 contacts. This is like probably ground, and then this forms like a gray code. So if you rotate it one way, these 2 get contacted together, and if you rotate the other way, it gets the other 2, and so it can kind of tell which direction you're moving it in, which is neat. But it doesn't keep state. There's no, like, it doesn't have any, like, memory, I think. It just knows, like, which direction you twisted it based on which contacts get connected one before the other. Power circuitry, this is the switches for, what are those switches? These switches are direction. Oh, the button left. Grab that. These do direction, these do rotation. Thanks. Sticky buttons. 2 little tactile buttons. And then, of course, infrared transmit, and the LED is in parallel. So they both go off at the same time. And that's that. And this is address. And then there's a little blob here. That's where the chip is. I'm sure it's a very simple, you know, they're making hundreds of thousands of these, so it's probably a simple chip that's just designed for transmitting infrared. This is the power transistor for the output. Okay, so we can put this back together carefully. Okay, like so. Like so. It's got a little bit of grease on it, which makes sense. Like, this is a little greasy. So now I'm a little greasy. So that's to protect it from oxidizing. Okay, go, 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 go. Okay. Reassembly. Good as new. So that's the remote. So, you know, it's $13, which it's like, you know, I don't think it's going to be possible or easy for Adafruit to get a distributorship. For Lego, I'm sure they have, you know, very high restrictions, but, you know, everyone has a store they can go to get these. You can buy them online, so I don't mind supporting
we'll ask.
this.
I mean, we've been turned down by everyone historically, and then eventually things change, but I'll try.
Yeah, it's worth asking.
Yeah.
Okay, so that's that. So back to business. So yeah. Simple but fun. Very easy. I like how there's a lot of different inputs. Address select. So I guess if you have multiple devices, you can select which address. And then, you know, rotate one way or the other. Button and select. Okay, so that's that. And then what did you want to look at on the computer? The blog post?
Yeah, we have a blog post about just the trend of some cardboard and robotics. So
okay.
Yeah, go ahead. Just you could do the highlight reel here.
So yeah, we were thinking also about not just robotics that move around. So actually, I'll tell you where this came from. So I was thinking about the robots that I had built in school, and at 6270 we built these roving robots, and they used a lot of infrared because again, it's inexpensive, it's easy. No certifications. You can blast a whole room very easily. And we used this thing called the Handy Board, which was... Oh man, I gotta figure out the... I just went there. Okay, the site's now down. What the heck? It was up like an hour ago. All right, I'm going to go to Wikipedia. It looked like this. It had infrared. You can see a little infrared transmitter and receiver here. And we were, you know, thinking, I was looking at this and I was thinking about the Handy Board and the Cricket Board and how those kind of robots were designed for rovers, but then they became used more for art bots and cardboard robots. And Phil and I were chatting about cardboard robotics and how, especially lately, we've seen more companies use cardboard as a structural element to create, like, not like trash bots, but they're like robots that can be made from low-cost materials that you have but are like fairly durable. So, Phil, you wrote this up today.
Yeah, this is a project from 2005.
So you had an iPod 15 gigabyte. Huge.
Yeah, I had like 100 of these for the project I was working on. I'm like, I gotta turn this into art. And
So
like
you
the
made
lights
these
would
little-
light up, and like I got them to move with some toy motors, but I'm like, one day,
So this is the box,
yeah,
and you painted it,
yeah,
and you drew, and then this is like the foam inside or something.
yeah, and you can have it move around and poke holes for LEDs and stuff.
Yeah. Hi, little robot, and then of course the Google Cardboard, which is well known. You pop lenses in. There's a little magnet and a.
Yeah, when you scroll down, you can see some of the stats. It looks like they gave away 10 million of them.
Oh, easily. Yeah. So there's knockoffs and variants, very successful. And then there was the TJ bot, which isn't like cardboard, but it's close enough. It's thick paperboard.
Yeah, could be.
I think it could be cardboard, but they were like, well, it's actually cheaper just to use. It's simpler because you don't have to stamp it. You can laser cut. Cardboard's hard to laser cut. And then the AIY vision and audio kit from Google, so that the cardboard stuff was working out. So they're like, okay, let's make this Raspberry Pi kit where the bot fits inside that cardboard box that you fold together. And they sold a couple thousand of these. Easily 10 or 20,000. And then of course this is now famous, the Nintendo Labo coming out in a couple months, where you fold cardboard around a switch to turn it into like a motorcycle or a fishing pole or a house or a piano or like something else here. I don't know what this is. Oh, this was a little bristle bot, which I thought was funny. So you turn this into a remote, you turn the switch to a remote control, and then the vibration motors in the Joy-Cons become a little controllable bot, and then depending on how you turn on each Joy-Con, you can make it move like left and right. And then people like making robot costumes with Make Do, which is kind of neat.
Actually, if you click the Make Do site real quick, or our site, yeah, we stopped these. So they're just screws for cardboard. They're cool. Good idea.
They're just really big. They're really big screws, and then they come with a saw as well.
Cardboard saw.
A cardboard saw. Yeah, I mean safe. Like you can't really hurt yourself. And then a little tool that helps you insert them.
Yeah.
And then there's this FM radio kit. I kind of vaguely remember this.
Yeah.
A couple of these got made, but it's a cardboard. It folds up. Cardboard computer.
Yeah, that was at the Greener Gadgets competition. I think you and we were at the same time when we did Tweet-a-Lot.
Yeah, this is like kind of a good idea, but also the computers do get very hot. I don't know if.
Yeah, that's what everyone's saying. I think it's okay.
I think it's okay as long as your power supply is okay. I think the moment something doesn't go okay, it'll get worse. A lot of cardboard speakers.
Yeah, that didn't work out.
But there's a lot of these foldable.
Yeah.
I mean, this is not the only one. There was tons of these cardboard boom boxes, cardboard speakers.
Yeah.
This
is neat. Play. Yeah. What's that?
This is a little.
Hello, and welcome to Lunchbox.
Here, I'll make the audio down.
Yeah, you can just skip to it.
So this is what we thought was really. This is kind of interesting. It's like, okay, take simple components with servos, and then you can turn them into robots, and then like it tells a little song, and you have cams and followers. I thought this is interesting.
Yeah.
Whack-a-mole. We did this project. It's the PZ1, the Pizza Box synthesizer DJ control, using Circuit Playground. This is the classic. This is one of our first projects, and silk screened on conductive paint to make a capacitive touch controller. A little robot. This is like Mike Barella did this project. It's just 2 pieces of round cardboard, 2 servos, a little bit of tape, and you put them together, and it's like, hey, I'm a little robot. Sound control robot. And then, you updated it with the box craft. So I guess when you get Amazon boxes now, they come with little cardboard cutouts.
This started, I think, February 1st, and there's a hashtag, and so...
Oh, wait, look, there's a cat.
Yeah, there's only, like, there's only a few people that have posted up about this, but I don't know if you even look in the boxes anymore, but it's in some Prime boxes.
Yeah.
So that's happening right now.
So cardboard robotics.
Yeah.
This is this low-cost infrared remote thing I was
wow.
thinking about.
That's cool.
Yeah, I mean, this is...
Oh, and you have that Wired article thing that I have?
Yes, this is... I was going to show the link. So this is the idea is that you plug this in and it becomes an IR remote. And this is like the fancy assembled version of your project.
Yeah, look at the date on it. I don't know if they have the original date.
Yeah.
That's 04, yeah, 14 years ago.
04 at 4:04.
Yeah, okay.
So yeah, you recorded the sounds on a PC and then put them on as songs.
Yeah.
We would I would just use like Python to generate them.
I didn't have Python back then.
We didn't have Python back then.
Well, I did.
Yeah, I think Python existed.
Yeah, it did.
Yeah.
But I didn't have it.
But it was a pretty new language.
Yeah, 14 years ago. I think Python's like 20 years old.
Is it 20?
I don't know. Go Wikipedia.
I think it maybe just started like 20 years ago. Yeah. So this is the idea, is just you plug it in and it's a remote control. So and then this is the nicer version. You can buy the protocol, and that's it. And then I was working on, I was writing a little script here which would just take the infrared data and decode it. So I've been working on that. I basically got it working. Maybe later on I'll show exactly how I wrote the code to do the decoding. But if you plug this in and then press a button, it's like, okay, if you press a button, it's X34, 80. When you press it again, it actually gives you a slightly different number. It flips a bit, so it knows if you every time you press a button, it alternates.
That's smart.
Which I don't know how they must have just a little bit of memory that they keep battery backed up. Maybe it's just extremely low power.
Maybe it's when you press it.
So it knows. It's like, okay, so it's like B5 and then it's 35 the next time. So, and then when you rotate these, it sends pulses and stuff. So just like
1989 for Python. So it's been around.
That's a lot longer than I thought.
Yeah.
I thought it only got invented in the late 90s. Okay.
All right. Well, that's everything.
So that's what I'm up to.
Some technical hurdles we worked out tonight.
Well, whatever.
No, that's a robot broadcast.
Robots. This is what we're working on with the robots.
Okay.
It's tough work, but we're doing it.
Yeah.
Okay, and we figured it out. It's the USB cables.
No, it's other stuff, but.
Okay. Well, we figured it out.
Yes, all.
Good work.
Okay, bye.
Bye. For real.